Hello, welcome again. We are covering the topic centrifugal compressor for civil service mains IFS and Gate Aerospace exam. And in the previous video, we studied one effect, that is compressibility effect. So now we will analyze it at the inlet of the impeller and diffuser. So at the inlet of the impeller, if we see this diagram, this is the inlet of the impeller. This is the inlet. So here the flow enters the compressor axially, and then it changes direction to radial direction. Here it enters axially and then it changes to radial direction. Okay. So this is your I tip and this is your I root, and here if we draw the velocity diagram here, then this will be your U tip, and this velocity is constant. This is your actual velocity entering like this, and then this velocity, relative velocity, will be maximum when we take this part. Okay. So at this part the flow changes its direction. So when the flow changes its direction and there is a high Mach number, then there is tendency for the flow to break like this. Okay. So here we have taken this U1 as I tip velocity, I tip speed, and this is your A1 actual velocity, which is constant, and this is your V1, which is your relative velocity resultant of these two. So now Mach number is calculated on the basis of this V1. So Mach number will be your V1 by root gamma RT, where T1 is your inlet static temperature. So here, so at this point, if the Mach number, or at this Mach number, when it exceeds unity or try to be near unity, then the shock can happen. So this has to give this Mach number has to give this particular tension by driving a compressor. Okay. So reading this out, consider now the Mach number at vital points in the compressor. Beginning with the intake. At the intake, the air is deflected through a certain angle before it passes to the radial channel on the impeller. Okay. There is always a tendency for air to break away from the convex space of the curved part of the impeller blade. Here at the inlet, the flow is deflected, so at the curved part there is a tendency for flow to break away. So here there is a point at which the Mach number will be extremely important. A shock wave might occur as shown in figure. Okay. The inlet velocity triangle for the impeller I is shown in figure B. This is your figure B. Here again the axial velocity is assumed uniform root to tip, so this is your uniform velocity. In that case, the velocity of air relative to the vane V1 will reach at the I tip, where the vane speed is greatest. So this is the vane speed at the I tip, and this will be the, this is greatest in the I, and because in the I the intake is taking place. So at the I, the maximum relative velocity will be at the I tip. The inlet Mach number is given by M is equal to V1 by gamma RT1, root gamma RT1, where T1 is the static temperature at the inlet. When the temperature T1 is very low, then the Mach number will be more than 1. So if this temperature is low, then Mach number can be more than 1, which may cause shock at the inlet, which cause high temperature rise. So this velocity, this V1 should be low to avoid Mach number to exceed more than 1. Okay. So this is the main criteria while designing Mach number for compressor.